geometric probability. We got to have a Bernoulli setting, so that means the success rate does not change from trial to trial. Let's suppose we're at a pizza restaurant and people have to be trained to make pizza really quick. I tried to make a pizza really quick back in the day and I couldn't, so I had to deliver them. I couldn't make them. But let's suppose the times it takes employees to create a large cheese pizza from start to finish, those times are normally distributed with a mean of 85 seconds, standard deviation of 20 seconds. Anybody that takes at least 2 minutes to make the pizza, that's no good. We can't have them on the pizza line. They're too slow. They're going to cost us money. So what is the probability that a person takes at least 2 minutes to make the pizza? Well, we go into a normal distribution and we say, okay, there's 120. We find this z-score and we look it up with normal CDF. We get 0.04. So now we come back over here and we say, okay, a success is that they took too long, 2 minutes too long. And so that's P, and P, the success rate, is going to be 0.04. So that's the success rate. Well, the failure rate is going to be 1 minus that, so it's 0.96. Then we can do a problem that might say, okay, what's the probability that the first person that's too slow to make the pizza is the third person that we randomly select? Well, we think that through. It's kind of nice to use S for success and F for failure. So we say the only way to end up with your first success being on the third trial is that you had to have a failure and then a failure and then a success. That's it, geometric probability. When does your first success occur? So in this case, it would be 1 minus P times 1 minus P times P. P is 0.04. 1 minus P is 0.96. So we just multiply all this together. That's the probability you get your first success on the third trial. What's the probability you get your first success on the fourth trial? Well, then that would have to be a failure and a failure and a failure and then a success on the fourth trial. So we would just add one more 0.96 right here. In addition to that, we could say, well, what's the probability that the first success occurs somewhere among the first 4 trials? Well, how about the first 3 trials? So what's probably that your first and only success occurs somewhere among the first 3 trials? So X, the random variable that keeps track of the trial in which you get your first success, would have to be 1, 2, or 3. So we can look at this a couple of ways. We can say, well, you could get your first success on the first trial. That would be a success. Or you could get your first success on a second trial, failure and success. Or you could get your first success on the third trial, which is a failure and a success. So now we go back and we write in the numbers. So the probability you get your first success on the first trial, that would be the 0.04. Or, so we would add to that the probability we get our first success on the second trial, which meant a failure and then a success. Or we can add to that the probability we get our first success on the third trial, which was a failure and a success. So we could add all those up, and that would be our probability that our first success occurred somewhere among the first 3 trials. Now, if we want to visualize this random variable, because we studied random variables here in the last few days, we'd say, okay, well, with geometric, the random variable X is the trial in which you get your first success. So we just saw you could get your first success on the first trial, that's a success, or the second trial, that's a failure followed by a success, or the third trial, which is failure, and a success. So we could just write in those numbers and fill in the table. That's the 0.04. This is the 0.96 times the 0.04. This is 0.96, and then the 0.04. Now, hopefully you realize theoretically this could go on for quite some time, but eventually the probabilities are going to get so small that they're negligible. It's as if nothing happens. So this is geometric. One way to represent this is if X is distributed geometrically, there's only one parameter, unlike a normal distribution that has 2, the mean and the standard deviation. There's only one parameter we need to know in a geometric probability, and that's the success rate P. Once we know the success rate, we can find the probability of getting a success on the third trial. We can find the probability that X could be any particular number. So get used to the nomenclature, success, failure, it's Bernoulli. But with geometric, it's a situation where X is on what trial will you get your first and only success.